So hi everybody, thanks for asking me to do a video on the liver and all the things that the liver does. Why do I think this is important? Well, I like to use the liver as a bit of a marker as to see what could be possibly going on in the body because often it will lead back to the liver, but not always, but it can also be an indicator of what is actually going on. So I thought it'd be interesting to do a video on this because a lot of people seem interested in this as well. So let's start off with what does the liver do? I like to talk about the liver as the factory basically because it produces so many important hormones and molecules. So let's start off with proteins. What proteins does it make? Well, the liver's going to make something called albumin, which I'm sure you've heard of. Now, albumin is not only a transport protein, which is going to transport nutrients and things around the body, but its main job is actually going to be an osmotic gradient within blood vessels. What does this mean? Well, if you imagine that you're sending blood around your body and they're going through your arteries, and once it gets to the target tissue, it's going to be having a pressure against pushing out of the vessels through the little tiny holes within the vessel walls, and it's going to push out things like oxygen and nutrients to deliver them to the tissues. But of course, you can't just push everything out. You need a force pulling back in, and that is albumin. And that's important because if we don't have that force pulling back into the vessels, then we won't be able to pull the water and essentially the fluid back from the area around our cells back into our arteries. Why does that matter? Well, we need to maintain a blood pressure, and we also don't want that water to just fluid to just pool around our cells because that creates something called edema. If you've ever seen somebody who's got a lot of excessive swelling, like for example around their ankles, that is something called edema, and that could be, it's not always, but it could be an issue with low albumin production. It could also be an issue of something going on with the kidney and we're excreting too much albumin, but that's for another video. What else does it make? Well, it makes other proteins called alpha and beta globulins, and they are also transport proteins. So they're going to transport around things like nutrients. As I've said here, we've got copper, iron. We know we need iron to make our red blood cells healthy and work well, to make our heme. We also need to transport our heme around on something called haptoglobin, because when we break down our red blood cells, once they've lived their life and they're getting too old and they die, we break down the components of the red blood cells and we put it on this molecule called haptoglobin, the heme component of it anyway, and that goes back to the bone marrow, which is where we make our new little baby red blood cells. So we can reuse that heme and put it back into new red blood cells. Retinol binding globulin is important for our vitamin A. We need vitamin A in our eyes. We also need it in our skin. And another place that people don't realize is that we need it for the conversion of our T4 into our active T3, for our thyroid hormone conversion, and that is aided by vitamin A. SHBG is for our androgens, so for example, our sex hormones, testosterone, estrogen, progesterone. We need something that's going to bind to these and take them around the body. And I didn't point out as well, the reason a lot of these will actually require a transport molecule is either because they are lipid soluble, which means they're not soluble in fluid, and or they are something like copper or iron, which is actually going to be negative in our body if it's not controlled and if it's not transported around properly. It can cause things like Fenton reactions. So this is why we need these transport globulins. Transcortin is for our cortisol. As you know, cortisol is involved in our stress response and utilizing our fuel sources like glucose and fat to convert it into energy when we're in a stressed situation. So that's important. We can transport that cortisol around. TBG is for our T4. So again, as I said, we will have that T4 and that's going to be sent around to our cells that require it and that need it. And then it's going to be converted to our T3, which is our active form, and that is aided by vitamin A. So these are all obviously very important to get our nutrients around the body. What about clotting? Well, we make these clotting factors 2, 7, 9, 10, C, and S in our liver. And so they are important, obviously, because we need to be able to blood clot. If we can't blood clot, we'll just bleed out from every little cut and abrasion that we have. We also need it in inflammatory situations. Say there's inflammation going on our blood vessels, we need to be able to, plug that hole essentially. And so these clotting proteins are important. This fibrinogen also gets made in the liver, and it's going to be converted to something called fibrin. Why is this important? Well, it aids in the clotting cascade. It's essentially going to be this mesh that will essentially jump over the top of the clotting factors when we need to clot, and it's going to hold and make it nice and stable and keep it together so it doesn't sort of easily break off when there's blood passing by. Anti-clotting proteins are also important, and they are also made in the liver. So we need a way to be able to break down our blood clots once we've formed them. So we need something called plasminogen, which is made in the liver, that gets converted to something called plasmin, which I'm sure you've heard of. We also make antithrombin 3. Now, antithrombin 3 I think is very fascinating, and I think it's very interesting in inflammatory situations like, for example, atherosclerosis, because antithrombin 3 works with something called heparan sulfate in our blood vessels. We make it all the time in those cells of our blood vessels, and it's going to be essentially sitting there ready to inactivate the clotting factors as well. So I think that's really kind of important to note. If we are trying to avoid having too many blood clots when we don't need them, we need these to be functional. Hormones that it makes are thrombopoietin. That is important in this whole clotting cascade as well, because we need platelets to be able to, form blood clots. And so this thrombopoietin is going to be made in the liver, and it's going to go over to our bone marrow. We don't just make our red blood cells in the bone marrow, we make our white blood cells, our red blood cells, and our platelets. And so this is going to go over there and basically tell the red bone marrow, we need to make some platelets. So we also make IGFs. What does that mean? That is insulin-like growth factors. And they're going to work alongside something called human growth hormone. And that's important because when we are releasing that out, we're going to help with the building of tissues, things like our bone tissue, our skeletal muscle. You might hear guys that are totally jacked in the gym talking about how we need our growth hormone to be increased and how they need to get enough sleep and things like that, because growth hormone is released mainly at night and after training. So we need these growth factors that are going to be released from the liver and work alongside that growth hormone to be able to stimulate growth in the body, just like insulin-like growth factors. Makes sense. Peptides like angiotensinogen, are going to be made in the liver, and this is basically just a precursor for something that is going to lead to the production of a increased blood pressure in the body. It will be converted to angiotensin 1, angiotensin 2, and eventually aldosterone will work with it to essentially just increase our blood pressure and help to keep our blood pressure nice and high when we need it to be. If we have too low blood pressure, we often hear about high blood pressure being an issue, but often too low blood pressure is equally as frightening, if not more acutely frightening, because if we don't have enough pressure going to our cells, we can't give them nutrients, and we can't get rid of waste products in our kidney either. So you need to have enough blood pressure working as well. Other things like our immune system need the liver because we need these complement proteins. So complement proteins and CRP work kind of together. And the best analogy that I've heard for these is that essentially complements, their job is to, when we have some kind of inflammatory situation, like we've been exposed to some kind of pathogen, like a bacteria, for example, these complements are going to be released to a larger degree by the liver, and they are going to go and essentially make that pathogen more tasty and appealing to our immune system, so our immune cells can come and eradicate it. If you imagine it like this, so the bacteria, when it's in our body, is like a piece of plain bread. The complement proteins are like Nutella. So if you put Nutella onto the piece of bread, then it makes it way nicer. So this is what the complement proteins are essentially doing to the pathogens, the bacteria. It's going to make them more appealing to be destroyed by our immune system, and it makes our immune system more effective, essentially. Last but not least are apoproteins. What are they? Well, think about your LDL. All of our LDL particles are LDL, VLDL, IDL, HDL, they all require proteins on them to be able to be recognized at our target tissue and essentially to be able to switch on other things in our target tissue like our lipoprotein lipase, because we need to think about it logically here. What are LDLs made for? Well, they're made in our liver. Then these proteins get inserted onto them, the apoproteins, and essentially then they're going to be released out by the liver and they're going to be sent out to our target tissues because, of course, there are target tissues all throughout our body that require cholesterol, triglycerides, and free fatty acids. We need these for energy, we need it for storage, we need cholesterol to make bile acids, we need cholesterol to make cell membranes, things like that. So if we are sending this stuff around, it's important to be able to get them to the tissues that they're trying to go to. And so these proteins are going to make them recognized and able to be used by our target tissues. So very important. Let's just quickly go back and have a look at these again. If one of these were to not being produced or several of them were not to be produced, you can imagine that the things that they are supposed to do in the body are not going to work properly. So for example, if you're not able to make these apoproteins properly, maybe those LDL particles won't be recognized at target tissues and your LDL will not be able to be taken from the blood and put into cells. So it makes sense that possibly if there's some issue with the liver and these aren't being produced properly, then you're going to have issues with your LDL levels. I think that makes complete sense. Immune proteins, if we have a low immune system activity and it's not working properly and we are not tolerating viruses and pathogens very well, it might be worthwhile looking at how the liver is going. Is there inflammation that's preventing us from being able to make all these immune proteins properly? What about our blood pressure? Well, this could be a number of different things. It could involve the kidney as well. It could involve our ability to excrete things properly. But it is worthwhile looking at the liver and seeing, are we making this protein properly? Is there some issue in this pathway? Our clotting factors, our ability to clot and our ability to break down those clots. Are we experiencing a lot of bruising? Are we experiencing a lot of blood clots? Could there be something going on in this pathway that needs further looking into? And of course, our hormones and our nutrients and their delivery throughout the body. If we're not able to, deliver them around, then of course we are going to have some issues. If our, for example, sex hormones are low in our bloodstream, it could be an indicator that there's something going on with it. Could we check the liver and see, is there something that is going wrong with the production of the molecules that are going to send these around? I think these are all worthwhile knowing, and it's really fun having somebody who can interpret this and help us to sort of figure out, what's missing here and is it liver involvement? And that's what I like to do. So what about the involvement in these other things? I think while we're talking about all this, let's talk about liver's involvement in all these things, because again, it can help us to sort of figure out what could be the issue going on. So vitamin D synthesis and calcium regulation. So when we think about our vitamin D, it's really, really, really important that we have our vitamin D levels nice and high, because it helps us to regulate our calcium levels in the body. And if you imagine that when our calcium levels drop down for whatever reason, like we're not eating enough or we're excreting too much, whatever it is, if we have low calcium in the body, our vitamin D is going to be activated, and that is going to help us to increase our levels of vitamin C in the body by greater uptake in our gut and things like that. And so it's important to have our liver working properly, because our liver helps with the conversion of the vitamin D, the cholesterol that we have in our skin, to the active form of vitamin D that's able to actually regulate our calcium. Sorry. Our vitamin D helps us regulate our calcium levels. So if our vitamin D is not being produced in its active form, we're not able to control our calcium levels in the blood. Other things that are important are vitamin K and our clotting proteins. Now, as I said over here before, the liver is heavily involved in making these clotting proteins, and also the conversion of vitamin K to its active form, which is going to activate our clotting proteins. So if something is going wrong here, then it makes sense that we're not able to clot properly or we're clotting too much. Vitamin A, as I said, vitamin A is needed to be sent around the body, and it's really, really important that our liver is working well, because it's going to convert our vitamin A that we get from our diet into the active form that can be used around our body. Vitamin A, we need the liver to be involved in our vitamin E because vitamin E is important for oxidative stress around the body, and it's important that our liver is working because our vitamin E is going to be taken from what we take from our diet, and it's going to be put within our LDL particles, and this will play a role in preventing oxidative stress. So let's just think about that for a moment. We know that oxidized LDL is the cause of atherosclerosis. So if we are not able to do this job of putting our vitamin E into our LDL particles and help to reduce the oxidative stress when these LDLs are delivered around, something to think about. Vitamin B12 is important, and that is going to be transported around on a molecule called transcobalamin, and that is made in the liver. So we need that to be able to transport our vitamin B12 around the body. It's going to help with hematopoiesis, which is the production of red blood cells properly. If we're low in B12, we can't produce healthy red blood cells, and we need it for our folic acid synthesis. Another thing is our iron. We need something called transferrin, which is going to be made in the liver, and that's going to transport our iron around the body. We also need something called hepcidin, which is our storage form, which is a molecule that is going to help us bind onto our iron and store it in the body so we can use it when we're ready to. And last but not least, we need the liver to be working properly because we have some proteins that are going to help to regulate the levels of copper throughout the body and its ability to bind on to its transporter, which is the ceruloplasmin, and send it around the body. So if there's anything going on with the liver and it's not able to do that job, it could be an issue about removing essentially mainly the copper and putting it into our bile so we can excrete it out of the body if we have too high levels, and also putting it on the ceruloplasmin so we can send it around. If you have any questions about this, please let me know. I'm sorry this video was so long, but there's just so much to cover when it comes to the liver. And if you have any of these markers that are out and you're looking at your blood work and you don't have any idea what's going on, you need a little bit extra help, please contact me because I'm doing consultations soon. So that would be great. If not, I hope this helps to be able to look at your own blood work and analyze it yourself and figure out what could be going on. Bye.